The universe is a bizarre place with its alien planets, mysterious moons and strange phenomena that are so out of this world they elude explanation. Continue on to watch this video to find out 5 weird facts about space. Movies are sometimes criticized when explosions in the void make noise. As the old saying goes, in space, no one can hear you scream. Without air there is no sound. Sound waves need a medium to travel through. Since there is no atmosphere in the vacuum of space, the realm between stars will always be eerily silent. Well, that is true. But only up to a point. Scientists say that for a short amount of time after the Big Bang, about 760,000 years, the universe was dense enough for normal sounds to pass through it. As it turns out, space isn't a complete and empty void, though large swathes of it are. The interstellar gas and dust left behind by old stars and sometimes used to create new ones, does have the potential to carry sound waves, we just aren't able to listen to them. The particles are so spread out, and the resulting sound waves are of such a low frequency, that they're beyond the capabilities of human hearing. Sounds travel as molecules bump into each other, the same way that ripples spread out when you drop a stone into a pond. As the ripples get farther and farther away, the sound gradually loses its force, which is why we can only hear sounds generated near to us. As a sound wave passes, it causes oscillations in the air pressure, and the time between these oscillations represents the frequency of the sound, measured in hertz. If the distance between the air particles is this wavelength, the sound can bridge the gap and the ripples stop. Therefore, sounds have to have a wide wavelength which would come across as a low pitch to our ears, in order to make it from one particle to the next out in certain parts of space. When sounds go below 20 Hz, they become infrasounds, and we can't hear them. And if you hear the sound of a planet or spacecraft exploding in a Star Wars movie, remember that the filmmakers are taking liberties. Chances are you wouldn't hear much of it at all. When asking the question how many stars are there in the universe, it's important to distinguish between the universe as a whole and the observable universe. Because the universe was born 13.8 billion years ago, we can only observe objects up to a certain distance from Earth. Light from more distant objects hasn't had time to reach us yet. And to answer how many stars are there, we must limit the discussion to what we can observe. Astronomers had estimated that the observable universe has more than 100 billion galaxies. Our own Milky Way is home to around 300 billion stars, but it's not representative of galaxies in general. The Milky Way is a titan compared to abundant but faint dwarf galaxies, and it in turn is dwarfed by rare giant elliptical galaxies, which can be 20 times more massive. By measuring the number and luminosity of observable galaxies, astronomers put current estimates of the total stellar population at roughly 70 billion trillion, 7 into 10 to the power 22. However, those estimates are dependent on the sensitivity of current telescopes. More recent estimates have upped the number of galaxies in the observable universe to 2 trillion, though many of these are tiny, fluffy galaxies with fewer stars. If a typical galaxy had 100 billion stars, then there would be 2 into 10 to the power 23 stars in the observable universe, 3 times as much as earlier estimates. But even this is still probably an underestimate, as more sensitive telescopes will continue to reveal fainter galaxies and stars. The Apollo astronauts' footprints on the moon will probably stay there for at least 100 million years. This is because the moon doesn't have an atmosphere. There's no wind or water to erode or wash away the Apollo astronauts' mark on the moon. That means their footprints, rover prints, spaceship prints, and discarded materials will stay preserved on the moon for a very long time. They won't stay on there forever though. The moon's still a dynamic environment. It's actually being constantly bombarded with micrometeorites, which means that erosion is still happening on the moon, just very slowly. If 2 pieces of the same type of metal touch in space, they will bond and be permanently stuck together. This amazing effect is called cold welding. It happens because the atoms of the individual pieces of metal have no way of knowing that they are different pieces of metal, so the lumps join together. This wouldn't happen on Earth because there's air and water separating the pieces. The technique was first recognized in the 1940s, growing in use and prominence during the age and advancements of space travel and exploration. The effect has a lot of implication for spacecraft construction and the future of metal-based construction in vacuums. Venus's rotation and orbit are unusual in several ways. Venus is one of just two planets that rotate from east to west. Only Venus and Uranus have this backwards rotation. It completes one rotation in 243 Earth days, the longest day of any planet in our solar system, even longer than a whole year on Venus. But the sun doesn't rise and set Venus like it does on most other planets. On Venus, one day-night cycle takes 117 Earth days because Venus rotates in the direction opposite of its orbital revolution around the Sun. Venus makes a complete orbit around the Sun, a year in Venusian time, in 225 Earth days or slightly less than 2 Venusian day-night cycles. Its orbit around the Sun is the most circular of any planet, nearly a perfect circle. Other planets' orbits are more elliptical or oval-shaped. One possible cause for the slowed spin is friction caused by Venus's thick atmosphere and high-speed winds. The motion of the atmosphere on Earth, for example, has been observed to affect the planet's rotation rate, albeit to a much smaller degree. Thanks to a heavy blanket of carbon dioxide air, the surface pressure on Venus is 90 times what we experience on Earth at sea level, and opaque clouds of caustic sulfuric acid constantly whip around the planet at hurricane speeds.